Hello, everyone. Welcome to another edition of Business Calculus. Quiz. I don't know if that echo was right. Anyways, Math 1325, Section 10.4. We're doing chain rule. So, chain rule, which I have already given you in previous videos, I'm going to go ahead and do it again and explain it maybe just a little bit more in detail or just re-explain it because I probably explained it fine in the last video. But hey, you know what? So we're going to do it again. This is your official formula. Blah. So the main thing is that you leave the inside alone. Do you have to, do I have to write that down? Leave the inside alone. And then you multiply by the derivative of the inside. Whatever. You're writing that stuff down, right? Right? So, example. We have this coolness, 2x plus 3 all to the fourth power, and they say, find the derivative. Okay, so the 4 comes down to the front, and you leave the inside alone. And then you subtract 1 from the power, right? Because it's 4, and then you bring it down, and you say minus 1 is 3. Done. We're done. That was it. Because you had a complicated inside, you now have to take the derivative of that and multiply it out here. What's the derivative here? Is just going to be that 2. Again, the 3 goes to a 0. And there you go. So now you combine these outsides. You got 8 times the original here. Now it's cubed. There's your answer. You're done. So that's chain rule. We're going to do not very many problems. A little bit more than the last section, actually, because chain rule gets confusing. I think that the main highlight here is like gotcha moments. It's like, oh, did you see that you had a complicated inside? So let's go through some of these and not get gotcha'd. Not get got? I don't know, whatever. So this is technically a chain rule problem. We've already seen this many times, though, where you take the negative 7, you bring it back down. So 9, you got your negative 7, e to the negative 7x. Again, remember to leave that power alone. So in this particular case, 7 times 9 is 45, e to the negative 7x, and you're done. No, it's not 45. Oh, man. So, it's okay. Look. We got calculators for that sort of stuff. Oh, yeah, it's 63. Okay. And I have 63 right in front of me, so. Oh, Chad. Yeah, that's my name. I'm Chad. Hello. So, x to the 5th. X to the 5th plus 3, all to the negative 2 power. And they say find the derivative. This is no problem at all. It's like, oh no, there's a negative power. Well, I don't know. Just put a negative 2 in the front there. And now minus 1 from the power. Minus 1. Negative 2. Minus 1. Look, I'll show you. Is a negative 3. Oh my gosh. I can't stress that enough. You're not like removing a number. You're saying minus 1. It's complicated inside. What's the derivative of the inside? Well, the 5 comes down with a now 4 power. 3 goes to 0, obviously. This is your answer, but of course we want to make it look pretty. So the 5 and the 2 make together to make a 10, x to the 4, and then the bottom, x to the 5th plus 3 all cubed. And there you go. Sweet. All right. I guess I'll just start here since I already scrolled. Next problem. So we got y is equal to, I got 6x minus 5 to the 1/2. I have x is equal to 1, and it says find the tangent line. This is why I do these problems, because it's like, huh? What do you mean by tangent line? And that's why I'm here to say, oh yeah, look, we've seen this before. And you could say, oh yeah. I guess, I don't know, maybe that's how you sound. Maybe, I don't know. I don't know. So I have to have fun here, you know. Let's find some derivatives. So again, we're needing the 3 different things. And that's going to be a y, an x, and an m. So I got my x. I need to find y. So let's find y by plugging in the x, which is a 1. remember that the half power is technically a square root. So you're saying like square root of 1. Again, that's 6 minus 5 is 1. So square root of 1 is a 1, just in case you know. So there's your y value. So we got a y. Now we need to find our derivative, because that's how we're going to find our slope. So the 1/2 comes down, you leave the inside alone, and you minus 1 from the power. If you are not okay minusing 1, that is why you have a calculator. That is okay. That is okay. That is okay. Derivative of the inside is a 6. And so technically what you have is 3 over the square root of 6x minus 5. Did you catch that? And this is your slope. This is your m, kind of. So first off, the half and the 6 make a 3, right? And then this negative means it's in the bottom, and that 1/2 means the square root. So blah, 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 there you go. You don't have to go and do all that, because ultimately we're going to just be plugging in the 1 to find my actual slope. And so you have 6 times 1 minus 5, which turns out to be a 1. Square root of 1 is a 1, so you got a 3. So there's your slope. So we got these 3 numbers that are important to us, 1, 1, and 3. Let's go and put them all together. Y minus y1 is equal to m times x minus x1. So y minus 1, because y1 is a 1, m is equal to 3, x1 is a 1. Where is my math for all this? Oh, it's right there. Okay, I'm checking. So cool. 3x minus 3. Add 1 to both sides. 3x minus 2, and this is what they want. They don't want you to type the y equals. I have an arrow. Does that mean we, like, continue? Oh! Yee! We're not done. That was only part A? So, continued. Part B, it says the tangent line is horizontal at x equals what? Okay, time out for a second. This is a really awesome concept. This is a really awesome concept where tangent line horizontal. Okay, whatever. I don't know why I said tangent line and horizontal. I don't really know what's going on. The tangent line of the function? Oh, right. Okay, time out for a second. Remember how they had like x equals 1 at the very beginning, right? That has nothing to do with the part B at all. So basically, it's everything we just did, but get rid of the 1. Go. So just kind of forget about that 1 exists, I guess. They're saying, when is the tangent line equal to 0? And so I don't know what this graph looks like. I'm just making it a cubic because it's not a cubic. I'm just making fun with it for a second. But a tangent line being horizontal means that you found a min or a max, which is super, super important to you business people, because you're finding the maximum profit or revenue, you're minimizing costs, all that kind of stuff. Minimizing material, you're maximizing productivity, all that kind of stuff. Okay, so it's a very important concept. The formula for this is very simple. It's y prime is equal to 0. That's what you're really wanting to do. So forget about everything we just did. Forget about everything else, okay? I'm just going to find my derivative. So my derivative was right here. Okay, let me rewrite that. So that was a 3 over the square root of 6x minus 5. And I'm saying my derivative should equal 0, solve for x. That's the goal here, okay? Look at it. I'm going to ask, what's x equal to? And the answer is you can't. Because whenever you have a fraction equal to 0, you have to look at the top equal to 0. And can 3 equal 0? No. So I'm going to write none, I guess. So the answer is tangent is never horizontal, okay? Tangent, never horizontal. So you click that button, okay? It's an odd case where they're trying to explain this really cool concept, and they want to like, ooh, look, we're going to find a min or max or blah, 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 and then they don't. Or maybe it is actually kind of equally fun because there is not a local maximum, so that you're not like hindered. I guess the more you do, the better it'll be always. I don't know. That's a whole other different reading into it. I just feel like that problem kind of like missed the boat a lot. But hey, you know what? I'm not the one making the homework. I'm just doing videos for you. And I guess I might be your teacher, so there's something, I guess. I didn't even do this problem. I didn't do this problem because I wanted you to do it, but I didn't. At the same time, I didn't want to like leave you totally hanging. So I wanted to kind of get you like a boost. Okay, so it's the same problem with the tangents and all that stuff, but this here I want to give you like the derivative for this one, and it's not hard. I need to find the derivative of this thing and put it down. So this is the ultimate chain rule thing. So I say, what's the derivative of e to the x? Well, it's e to the x. So I leave it all alone. And then I say, oh, I had a complicated inside, so now I need to multiply by the derivative. And what you've been doing is this, but now it's on a higher scale, okay? Normally, when we had like e to the 2x and the derivative was 2 e to the 2x, it's not a coincidence that the derivative of this is the 2. Do you see that? It's not just literally the number in the front, it's the derivative. So what we've been doing is like a simplified version for the whole time. Now, actually doing chain rule is that we have to say, oh, what's the derivative and multiply by it. And that's what I'm doing here. If that didn't make a lot of sense, just do what I'm doing, I guess. Hopefully it made sense. Why am I repeating my same thing again? Blah. So it's 7 times all that stuff. So, because I went crazy on the side there. I want to do the 7 with both of these guys. Mush them together? I don't know. Yeah, I'm just going to put it in the front. Don't distribute. I guess. Okay. And then that's your derivative. And then, so that's your slope. And then you plug in the numbers and da, 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 da. So what if they had said, because I actually did not do this problem, I just stopped. But what if they said that they wanted to know whenever the derivative is equal to 0? What I would do is set this whole thing equal to 0 here, but because I don't have a fraction anymore, I don't have to like look at that. Is the exponentials ever equal to 0? The answer is no. They're always above the x-axis, so they're like, this doesn't count. And the 7 doesn't really matter either. It's only down to this little factor, right? Y'all know how factors work, right? So the factor, set it equal to 0, solve for x. And so 2x minus 5 is equal to 0. I'm going to move the 5, divide by the 2, and so I got 5 halves. That would be my answer. So if they said, where is this derivative equal to 0? So then it would be 5 halves. And what that means, I don't know what this graph looks like. I'm just saying. But maybe it had something to do like this, and then it like took off. Hold on. Something like that. So right here at 5 halves is where you would have a minimum, or maybe it's a maximum. I don't really know what they're going for here, but that's just a thought. Cool. Yeah, that was a lot of talk. Okay, so there's a lot of talking about a problem I really didn't even do. This is actually a 3. I'm sorry. So y is equal to ln of, and I'm going to write what they have. I'm going to draw it the way they'd have it drawn on the homework. And I just get really infuriated by their notation because it's not wrong, but it's lazy. So it leads people astray. So is the ln, is this whole thing to the 3 halves? Or is it just this inside part to the 3 halves? I believe it's just the inside part. And I don't think I actually checked it. I mean, maybe I did. I think maybe I did check this one. But yeah, just that's what's going on. It's just think of it like on the inside, okay? And if I got it wrong, then you can yell at me or something like that. I don't know. Leave it in the comments below. So let's do this thing. This is a big chain rule. This is actually a big time deal. So the derivative of ln is going to be 1 over stuff. Like, let me just write my own formula for that because I really like this formula. So I've got ln of stuff, and so then my derivative would be 1 over stuff. And now, like, to make the whole thing further, it's stuff prime on the side, but the derivative of ln is 1 over stuff. And I like to say that. It's like one of those memorizing formula things. I say 1 over stuff so that whatever I have, I'm just going to leave it down there as a whole bunch of stuff. 1 over stuff. We just did the whole derivative. We're great. Excellent, excellent. But that's a complicated stuff. So I need to take the derivative of this guy now. Now it's going to get a little bit weird, but essentially I'm saying, what's the derivative of this guy? Well, the 3 halves comes down to the front, so I got 3 halves. And then I'm multiplying that by this guy here. Don't change the inside. Now minus 1 from the power. minus 1 from the power. Here, look, minus 1. Oh, 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 oh. And so then I say, oh, look, chain rule again. And so then I got 8x to the 7th. Whew, that is a monster. And that's fine. We can figure this thing out. So I want to mush together the things that I need. And I would say that the 3 and the 8 make a 24. And that, and that 2 is going to cut it in half, making it only a 12. So I got a 12 now. And then notice that we have a square root right here. But what you're going to see is that we have this 3/2 business now in the bottom. This is a conundrum, okay? In fact, I want to go back. I want to go back and not have the square root, but I want to do a 1/2 power again. Erase. You do use a pencil for math, right? Okay. This is one of those conundrums where whoa. I messed up one thing. Look. X to the 7th. Forgot about that guy. It's a good thing I did all this math ahead of time. The conundrum is that we're needing to take that numerator and denominator and somehow mush them together somehow. Like these guys here are going to become something. So the bases are the same, and I'm dividing the bases, which means I'm subtracting the powers. Okay, so like going way back, I got b to the m, b to the n, and this is b to the m minus n. Okay, so I'm subtracting. I'm subtracting my powers. And so 1/2 minus 3/2 is a -1. And so I'm going to write it. I'm going to write it just as I would here. Okay, so I got the 12x to the 7th. And now I say I have my single base to the -1 power. That is technically correct. But because it's a negative, I want to be able to put it down in the denominator as well. But as a single power, as a 1. It's a 1. You don't have to write a 1 there. You don't have to write a 1. You're done. That's it. Now, I probably made that problem a little bit bigger than what I should have, but the main part is that you had the chain rule, and then you had another chain rule. And after that, it was just simplifying and stuff, okay? It's still a big problem. It really is, and that's why I'm doing these. I don't want to like leave you hanging on the big ones. I mean, there are a couple big ones that I'm not doing. I already did that problem. But I'm not doing them because I'm doing problems very similar. I wouldn't want to leave you hanging. And if you do find something I totally missed, you can tell me, and I might make an edited video. Who knows? You know me and my editing skills here. So I have this crazy thing here. And it says, find where the tangent line is horizontal. So, I mean, horizontal, tangent line. Basically, again, I'm saying that my y prime is equal to 0. So the goal is going to be to find the derivative, and then I set it equal to 0. And from there, we just kind of figure out what's going on. This is not too bad of a problem. This is a quotient rule, so we got my high and my low. And so my derivative is going to be low d high minus high d low divided by the square of what's below. So low d high is a 1 minus high d low. So that's kind of weird, but there's a 3 in the front. Leave the inside alone. Now it's a 2 power. Derivative of the inside is a 3. All divided by the square of what's below. Now that was a 3, and then I'm now squaring it again. Like there's a 3 and now there's a 2. So let's kind of figure this thing out a little bit here. I got a cube times 1 doesn't really change anything. Here I've got 3 and 3 make a 9 with an x, makes a 9x, and then I have that same base to the 2 power. And then powers of powers multiply. So you should have a 6 there now. Hey, what do they have in common? This whole 3x minus 5 business. So I'm going to pull out what is in common, my common factors, I guess you can say, would be the square. They at least have both 2 of them. And so we have a single 1 that's left over, and then that 9x. That's still a 6. That's still a 6. There we go. You don't need the 1 power, and therefore you don't really need these parentheses. You can combine like terms here, and these guys are going to make a -6 in the end. And that's fine. We're going to see that in a second. But see how these are going to cancel a little bit? So I got 2 in the top and I got 6 in the bottom. So I'm going to get rid of 2 and be left with only 4 down there. Because this was basically 2 and 4 makes the 6 there. So in the top I got a -6x minus the 5 all divided by this dude right here. And oh, don't box it in, don't box it in. Okay, that's my derivative. Okay, but the goal was to take this and set it equal to 0, okay? When you have a fraction like this, it's going to be the top equals to 0, like exclusively. So I'm saying that -6x minus 5 is equal to 0. Let's move the 6x over. Divide by the 6. And there's your answer. -5/6. I believe they want a fraction, so there you go. That's what I have in my notes, at least. You did it. You did it. So that's pretty cool. Whew, that was a pretty big quotient rule. And you can see I'm trying not to get like away from the hard problems. I'm not saying like, oh, that's a hard problem. I don't want to do that. Because if it's something like that, I probably already deleted it. Or I'm showing you. This is the last problem I have in this section. And that's fine. So x is equal to 78 square root of p plus 16, and then minus 350. That minus 350 like threw me way off a lot, and I'll show you why in a second. So part A, it says find x prime, and that's it. Part B will be to like use it. Now I want to just do a couple little side notes. You see how my square root ends? And I put a little down tick. It's saying like that's the end of that square root, because I don't want to think that minus is never, and then like all of a sudden I'm including it or something. No. It's better to have the down tick right here right now instead of having it just hanging and you're like, I don't know which one was it under, and then all of a sudden you magically make it underneath that as well when it's not. So just down tick it right now while you can. Okay, so we need to find the derivative. And this is a 1/2 power, so if I were to rewrite this, it would look like this. So the 1/2 is going to come to the front. I leave the inside alone, and I minus 1 from the power, minus 1 from the power, and then this guy goes to a 0. So I guess that 350 didn't matter. It does. So anyways, this right here turns out to be a 39. And because this is in the denominator, right, that's a negative, and it's a square root technically, I'm going to say this. So this is actually the answer for part A. And then part B, it says P is equal to 84, find X prime. So this is where the 300 got me in trouble, because I just didn't look high enough. I had thought, it said equal to 0. So, no. It's all part of there, of course. So I need to plug it in. This is just a plug it in problem. So 78 square root of the 84 plus the 16, and then minus the 350. Got to do that part. When you do that math, you know what? I got a calculator. Let's do it. So 78... times the square root of this thing plus that thing. Then minus the 350. Yep, there you go. Equals 430. That's your first answer. So then it says find the derivative. And we already have the derivative, so I just plug it in now. So 39 over, and then the square root of 84 plus the 16. I think that's 100, isn't it? Yeah, because it turned out to be 3.9. So, cool. There it is. And that was the last question of this section. So, cool. Thank you very much. Have a great day.